Hi ladies, this is the second lesson in Chapter 7. Chapter 7 is all about establishing similarity. So in this lesson we're going to look at similar triangles. So we looked at the idea of similar versus congruent in the last lesson, and we're going to explore that a little further. So the first question that I have for you, and this is not on your note sheets, but you can see it up on the screen, is what is the same about congruent triangles versus similar triangles? So think of what it means for a triangle to be congruent. And maybe the first thing you think of when you think of congruent triangles is the CPC-TC, which means corresponding parts of congruent triangles are congruent. And this parts means angles and sides. So corresponding angles and corresponding sides, those are the corresponding parts of congruent triangles. They have to be congruent. So if you think about what is the same about similar triangles versus congruent triangles, is in both similar and congruent triangles, angles are congruent. So that is something that's the same between the two. Now, what's the difference between similar and congruent? So if in both of them angles are congruent, what's different about similar and congruent triangles? Well, in similar triangles and congruent triangles, the angles are congruent, but in similar triangles, sides are proportional, and in congruent triangles, sides are congruent. Right, so let's think about congruent shortcuts. And we can use these congruent shortcuts to look at similarity with triangles. So if you remember back from Chapter 4, our congruent shortcuts are, if we have three corresponding sides congruent to three corresponding sides, the triangles are congruent. If we have a side, an included angle, and a side, congruent to a side, included angle, and another side of a triangle, triangles are congruent. If we have side, angle, angle, or if we have angle, an included side, and another angle. So those prove congruence within our triangles. So remember that angle, angle, angle does not show that the triangles are congruent. And actually, if we have an angle congruent to an angle, so if A is congruent to D, for example, and then we have another angle, B is congruent to E. First of all, just looking at this triangle, they do not look congruent. Triangle ABC clearly looks very much smaller than triangle DEF. So these are not congruent triangles. But what do we know about them? So if angle A and angle D are congruent, if angle B and angle E are congruent, what's true about angle C and angle F? Well, let's assign a variable to angle A. Let's say that angle A is X. That means angle D is X. Let's say that angle B is Y. That means angle E is Y. And let's say that angle C is Z and angle F is P. Well, X plus Y plus Z has to equal 180 degrees. And X plus Y plus P also has to equal 180 degrees. So if these two are equal, then these two expressions are equal. So X plus Y plus Z equals X plus Y plus P. If we subtract X from both sides, and subtract Y from both sides, that tells us that Z has to equal P. So because both triangles have to sum to 180 if two angles are congruent, so if A is congruent to B and A is congruent to D and B is congruent to E, then C and F have to be congruent. So when we're looking at similar shortcuts, you can prove similarity between three angles of triangles, but really all you need are two angles. So if you know that two angles are congruent to two angles in another triangle, then the two triangles are similar. So you can have all three angles, you can have a side and two angles, you can have two angles and a side, you can have angle, side, angle. So it includes all of those shortcuts, because if you have two angles of a triangle, the third angle of the triangle is going to be congruent to the third angle of the other triangle. So those two triangles are similar. All right, now another shortcut is side, side, side. But the difference between similar and congruent triangles, again, is that the sides are proportional. So three sides of one triangle are proportional to the three sides of another triangle, then the two triangles are similar. And then lastly, if you have side and an included angle and another side, so if the two sides of one triangle are proportional to two sides of another triangle, and the included angles are congruent, then the triangles are similar. So let's look at this problem. Is triangle MOY congruent to triangle NOTY, or why not? Well, let's look at our options. We can either show that two angles are congruent, we can show that three sides are proportional, or we can show that an included angle and two sides are, included angles congruent and two sides are proportional. So it looks like we have two sides of each triangle and we have an included angle as congruent. Okay, so O is congruent to O. Now let's look at this side and this side. So is 96 to 81, is that ratio equivalent to 104 to 91? You can do this a couple ways. You can cross multiply. So 96 times 91 is 8736. And oops, this should be 84. So 84 times 104 is 8736. So 8736 equals 8736. So yes, they are congruent. Or you could do it the other way. You could look at those ratios as fractions. So 96 divided by 84, is that congruent, or is that equivalent to 104 divided by 91? And yes, 1.14 equals 1.14. So yes. And we know this because side, angle, side. two sides of one triangle are proportionate to two sides of another triangle, and the included angle is congruent. Let's take a look at the next example. Here, we're looking for H and K. So we're looking for this side, we don't know what it is. And we're looking for this side, and we don't know what it is. Now, what we do know about the triangles is there are two angles that are congruent. This angle is congruent to this angle, and angle A is congruent to angle E. Okay, therefore we know that these two triangles are similar. If the two triangles are similar, that means corresponding sides are proportional. Okay, so GAH to JE has to be equivalent to the proportion of AS to ET, which is 24 to 30. So in this problem, we're going to cross multiply. So we have 30H equals 24 times 50, which is 120, 1200. And now we're going to divide each side by 30 to solve for H. So 120 divided by 30 is 40. So H is 40. And then the second problem is to solve for K. So we can do this the same way. So K, well, we'll do the left triangle first. So 32 to K is equivalent to 24 to 30. Again, we're going to cross multiply. So we get 24K is equal to 960. Divide both sides by 24 so that we can solve for K. And this one I'm actually going to use my calculator. And we get 40 again. So K is equal to 40. Now, you don't have any units on here, but if it gave you units, you would need to make sure that you included your units in the final answer. All right, let's look at one more. It says that TA is parallel to UR. Is angle QTA, so is this angle congruent to angle TUR? Think of your corresponding angles that you have with parallel lines. Yes, those two would be congruent because they're corresponding angles. Now let's look at the second question. Is QAT, so is this angle congruent to ARU? This angle? Yes. They are congruent because they are also corresponding angles. And then lastly, y is angle QTA. So I'll outline that in blue. So y is this angle similar to angle QUR. These two are similar because corresponding angles, they have two sets of corresponding angles. So yes, they are similar, first of all, because corresponding angles in the two triangles are congruent. So then lastly, if we know that these two triangles are similar, we need to solve for E. So let's look at our proportions that we can set up for our sides, because if the triangles are similar, then the sides are going to be proportional. Okay, so this whole side of the large triangle corresponds to the small side. So the whole side, we'll write the smaller number first. So the small triangle has a length of 3. The larger triangle has a length of 3 plus 5. That has to be equivalent to 4 over the whole side, 4 plus b. Okay, so let's just simplify this a little bit. So we have 3 to 8 has to be equivalent to 4 to 4 plus b. Okay, now let's cross multiply. 4 times 8 is 32. That has to equal 3 times 4e, 4 plus e. So to simplify this, 32 equals 12 plus 3e. We're distributing the 3. Subtract 12 from both sides, we get 20 equals 3e. So lastly, now we can just divide both sides by 3, and we get e equals 20 over 3 units. Does it give us units? Does not give us units. So whatever 20 over 3 is, now if you write it as a mixed number, it's the same thing. So you would have 6 and 2/3, whatever your units are. Right, and then this last question, the extra example asks, why are these two triangles similar? Well, let's look at our possibilities. So we can either say that all 3 sides are proportional to all 3 sides, all 3 angles are congruent to all 3 angles, or a side, 2 sides are proportional and an included angle. Well, we know that these 2 angles are congruent, so let's start there. And then the other thing it gives us is that those 2 lines are parallel. So if these 2 lines are parallel, imagine this is a transversal that's cutting across those parallel lines. Alternate interior angles are congruent. Now, same with this transversal that's cutting across those parallel lines. Alternate interior angles are congruent. So we actually have angle, 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 but we only needed 2 angles that are congruent. So now the next question is, now that we know that those 2 triangles are similar, what is x? Well, 6 corresponds with x. So 6 over x equals corresponding with 4. Now, if you're having trouble figuring out which sides correspond with which sides, EC or CE right here is going to correspond with EE. That's how the statement of similarity is written. Corresponding sides are proportional. Okay, so 6 to x equals 8 to 4. So we can cross multiply here. So we say 24 is equal to 8x. Divide both sides by 8. And x equals 3. And in this case, actually, it does give us units. So we say 3 centimeters. So please jot down any questions that you have from this video, and we can go over them in class the next time I see you.